All right, so today we have Jeff Hawke, CTO at Odyssey. The website is odyssey.ml. Taglines are we're building the world simulator, and also from any starting image, Odyssey 2 Pro, a frontier world model, generates continuous interactive simulations. And with that, Jeff, welcome to the podcast.
Thank you. It's a privilege to be here.
So, we'll talk about world models in general, but I'd like to kind of understand more about this new frontier model, Odyssey 2, which
Mhm.
I am sad to say I just got my API key a few minutes ago, so I haven't tried it, but I will.
You
Uh,
should.
so for our listeners, I guess uh, developer focus right now, you get an API key. And so can you just walk us through kind of like the basics of what a developer should expect uh,
Mhm.
with Odyssey 2 Pro?
Yeah, sure. So world models are a new category of AI model that sits somewhere between sort of an LLM, as you might know them today, and generative video models, which model discrete clips. So a good way to think about this is an AI model that predicts potential futures and gives you this sort of continuous stream of intelligent pixels which you can interact with. And the important things to note here are firstly, it's a continuous stream, meaning it's not just a bounded clip. And secondly, that you can interact with it essentially as the stream evolves. And that is a property that is uniquely possible by training this as a world model. So what that means is when you get your API key and test it, you'll be able to basically go and essentially stream. Think of this as simulate potential futures and manipulate them as they evolve. So you might seed it with an image, you might seed a world with text, and then as the world updates, you'll see video stream back to you, and you'll be able to adjust how it evolves and interact with it. Maybe manipulate the scene, that kind of thing.
So it uses the phrase frontier model, just
Mhm.
like people are familiar with foundation models and frontier models that are mainly, as you mentioned, LLM based, right? So text. So in that case, in the LLM case, people who are listening to the podcast are broadly aware that these are trained on internet data.
Mhm.
There's lots of data to train with. So in the case of a model like yours, what is the training data?
Uh, Large scale public video is the majority of data. So you can think of this as if you think about what the best source of learning a world model, where would you find that? The volume of video that is produced by the world is enormous, which is great. And that gives us quite a different set of constraints from language. Maybe to be more specific, using some sort of napkin maths, the volume of video that is produced every single day on the internet is greater than any one company could possibly train on in building a world model, which is a very unique situation compared to language where the volume of training data is proportionally much smaller. So it does give us quite a different set of constraints. Um, so you could think of this as learning how the world evolves from trillions of observations of visual observations. So think about this as video clips and the transitions that happen during those.
So text has a temporal nature to it in the following sense, right? So if I ask, give me the most recent analyst reports of, or I want to learn more about NVIDIA, and
Mhm.
then you'll tell the language model, give me your most recent data. So in the
Mhm.
case of video, I suppose there's also a temporal nature to some
Mhm.
extent, right? So there's
Yeah.
current events as well as historical events, right? So
Mhm.
you can ask, hey, here's an image, place it in, I don't know where, in the middle of the US in 1920, right? So
Mhm.
something like that, right? So you folks also kind of keep track of temporal nature,
Yeah, I'd
the
say
timestamp of when the video was created, in other words.
we do, but I would say the primary area of focus in world model development is more think of this as like a sequence of how the world evolves from visual observation. So we do keep track of the timestamp for videos, yes, but it's the bigger factor is I guess it's a more granular timescale that most R&D in this topic
And
focuses
it's
on.
it's also depends on the use case, right? So
Correct.
the historical video example that I alluded to was if you're making a documentary or
Mhm.
something like that. So I guess you're very early on, but as far as you can tell, what are some of the use cases that people are trying?
Uh, the list is long. So one thing that's particularly compelling about this, if you build these models as open-ended general purpose models, much like you might think about an LLM, you get, frankly, quite a long list of potential things you can imagine doing with this. And from my perspective, what's particularly exciting is the fact that this will be a new category that is of the scale of LLMs, where you do have all of these different things you can do with them. Now, as a category of models, they did originate from more narrow domains. So think of this as autonomous driving. Think of this as uh, world models built for platformer games, for example. And what we've seen really in the past 6 to 9 months is this broadening into general purpose models. It is early. Uh, my mental model is I would think of it as sort of the GPT-2 era of world models. This is mass exploration, not mass commercialization. And we're seeing that happen at the moment. So to give you some examples, games, a huge industry, and I think this gives you a large variety of ways you could create different gaming experiences that are very difficult to create with current technology. Think about choose your own adventure type games. Think about having interaction modes that are very, very difficult to simulate in a game. Even things from sort of behavioral interactions with other characters and people. You can do that with current tools, but it's immensely difficult and expensive to do so. So in most cases, the game experience is simpler. To use other examples, think about this as everything from sort of retail, where you might sort of interact with a sort of a billboard sort of in a shop, through to live events where you have sort of displays that might sort of react to the crowd behavior. And
Wow.
all of these categories of use cases can be enabled by a world model. And this is in addition to the industries where they originated, such as robotics.
So yeah, that last example of interaction. So basically, that's real-time inference that
Hmm.
looks realistic enough. There's no lag, right?
Hmm.
And so
Streaming in real
so
time.
I would imagine, Jeff, one big area would be content generation, right? So I mean, people need stock video just like they
Hmm.
need stock photos. Hollywood for special effects,
Hmm.
potentially, right? So, but as you said, we're in the early stages. So, at a high level, architecturally, this is similar to what people regard as kind of the backbone of LLMs, which is transformers.
Yes, I mean we use transformers. Transformers underpin almost every frontier AI model that exists today. They're very generic, very expressive form of model architecture, and it's more how you frame the problem in your training regime.
And
But yes, we use
then,
transformers.
and then again, at a high level, a lot of people think of LLMs as some sort of next token prediction
Hmm.
machine. So this is would be like the next frame.
I would think about it as next future, a little bit more general of that. As in, if you think about what could happen next, is maybe a good way to think about it. So you know something about the state of the world, you know some local context, maybe you know some global context, and then essentially what the model is doing is saying, well, given some change that is going to happen in this environment, what's going to happen next? And then you're essentially querying it for potential futures. And you can query it at different times. You can then test counterfactuals with this, depending on what action conditioning you're providing to it. And frankly, it gives you quite a lot you can do with it as a foundational piece of technology.
So for the younger listeners who weren't around Jeff for GPT-2,
The dark ages.
can you remind them of some of the limitations of GPT-2? One of my recollections was it was so it was very prompt sensitive.
Mhm.
Like if you just somehow include the space, then the whole thing just kind of changes dramatically. So what were
Yeah.
some of the limitations of GPT-2 as you recall it?
Yeah. So maybe sort of to index it in time, if anyone
Yeah.
remembers sort of Jasper as probably a good example of a company that was
Oh
working
yeah,
on
yeah.
marketing
Oh
copy in
my,
that
my
era.
God, there was like a hot
Mhm.
company at some point,
Hugely
right?
hot company,
Yeah,
hugely
yeah,
hot company.
yeah.
And it was one of the great examples of people exploring what could be done with the models and people realizing that this was not too far away. Um, to give you examples of potential limitations of that era, you're completely right to point out to sensitivity to prompts. The models were definitely more prone to hallucination. We hadn't yet worked out how to bring in essentially like recent data into how the models were able to act with data beyond maybe the training window. Similarly, there was another problem which is actually quite similar to world models where you would go into these sort of um, maybe like, let's call it like a doom loop where the models would basically cycle and you would basically not get your stop token and it would spit out garbage infinitely for you. And so there was a lot of work to be done, and all of those problems have been solved within a year or two, really, of that era. And frankly, everything
And
post
and
GPT-4,
the
I'm
context window was super small
very short.
relative
Yep,
to what we have now, right? So
correct. Yep.
and so in your case, so what are some of the limitations? I guess one limitation that I suspect is that you can only predict near
Mhm.
future,
Yes,
right?
exactly.
So
Um,
measure near future.
so there's kind of a number of
If I give you an image and
Mhm,
then I give you a really detailed spec and prompt, what
mhm.
can you do? What can you do with that image?
So there's sort of two main difficult development areas which really only have been possible in the last, really in the last month, excuse me, last 5 months, last year. Um, one of which is basically sort of the length of video or length of contiguous state you could generate without the models becoming unstable. So this is actually quite similar to what the failing mode we saw with LLMs spinning and
And
spitting out garbage.
unstable in this context means just it just can just the
Yeah.
behavior is just completely
So
unpredictable.
correct. So
Yeah.
what is basically happening under the hood is you're essentially accumulating error in your tokens, essentially. And as a result, the machine learning term as you go out of distribution, and the model just essentially generates garbage. So the way this manifests is you sort of simulate forward, and essentially it would degrade into noise or to mush. Um, so
Literally visually.
visually correct.
Yeah, yeah.
So you would get weird colors.
Yeah,
Imagine psychedelic rainbows.
yeah. But then
So
Jeff, can you then take, okay, so the first 3 seconds were great. I'll keep that and then I'll feed that to the model.
so
Will that help?
so the big unlock in research really has been the shift, sort of since mid 2025, where there's a huge amount of progress has been made by us and the academic research community as well, where the ability to get the sort of stable video streaming for much longer periods of time is substantially better. I won't claim it's solved. This is definitely still a research problem.
And define much longer. In,
So mid 2025, I would say state of the art is 15 to 30 seconds at most, in terms of contiguous prediction. And today, I would say it's 1 to 2 minutes. There are ways of getting sort of further stability, but they give you other constraints on your simulation.
and this, so that generation is, I would imagine, compute intensive GPUs,
Mhm.
right? So you can't offload that kind of inference to CPUs, right? So
No, we we work some Hopper GPUs quite hard.
yeah,
And
yeah.
one thing
So
that's
to get those few minutes, you have to have a lot of hardware already, right? So,
yeah, it is quite a different computational profile from LLMs. One way to think about this is when you're generating a next frame as your potential future, you're generating sort of a whole batch of tokens all at once. And that's a sort of a different access paradigm to LLMs, where you tend to have essentially a large fetch to memory and a small amount of compute. Whereas with world models, you have a small fetch to memory and a lot of compute. Um, and as a result, we tend to be more flops limited or compute limited on the GPUs, and we tend to run them very close to the maximum computational output.
So you use the phrase world models, which is
Mhm.
a bit of a confusing marketing term. It's like big data back in the day. So there's
I
world models
yes.
in your sense, which is a world simulator. There's a world model in the Sora sense, which is like a video generator. And then
Mhm.
there's the Fei Li world model, which is,
Yep.
I think, a 3D mesh kind of thing. And then I think the robotics people may have their own usage of the world model phrase. But anyway, so
Mhm.
let's just take those two. So the Sora, Fei Li world models, how does that differ from the world model you're building?
Mhm. So there's really only one canonical definition of a world model. It was coined by a paper in 2018, Harish and Huber.
That's what you think, but now marketing has
True.
taken over.
That's true. And I liked your blog post. I think there is more work that's needed to
Yeah,
be done in terms of defining this category.
yeah.
And you're completely right to say that the term is being used quite
I think
loosely.
even Jan LeCun uses it in some notion of it, right? So yeah,
Yeah, so maybe it's sort of my mental framework really is
yeah.
there's sort of four major categories of model. There's the canonical definition of a world model, which essentially the model is learning how the world evolves. So this category of model really stemmed from the robotics and reinforcement learning community. It stemmed from a Neurips paper in 2018. It was picked up by a number of other folks, and essentially that category you could think of as this world or neural simulator. Specifically, what that means is you have some learned state. You're providing it with the model with some action, and the model is predicting a potential future. So it's a pretty simple framework. It's quite difficult to get them working well, but it's a very generic framework. So Jan LeCun's JPA paper you refer to was a specific proposal in 2022 of how you should think about building a world model. There's a few things he suggests essentially adding to that framework. I think the jury's still a little bit out about whether they're right or wrong. My view is we'll follow our nose based on the research results we're seeing. Um, uh, Second category, I would define as spatial intelligence, and this is more the sort of the world labs category. And the way I would think about this is models that learn how the world appears, and that is quite a uniquely different thing to how the world evolves. On the one hand, you've got dynamics and sort of prediction of future state. On the other hand, you've got structure and visual appearance.
So stop here for a second. So for our audience, what would be the difference in use cases between those two?
So, world models as a category
Yeah.
lead to imagine going to your favorite LLM, and instead of being presented with a chat box, you're presented with an intelligent stream of pixels which can talk to you, and you talk to it, it talks back to you, it morphs into what you want, and you can interact with it live. So world models, the canonical definition, lead to that future. Spatial intelligence is a wholly different category of technology. The main applications or usage of it really is in 3D toolchains. So anywhere where you need a specific 3D environment for some reason, it's applicable there for sure.
So
But
Autodesk kind of.
Autodesk game like current engine environments, Unreal, Unity, etc. Any use case where you need explicit
So it's
3D structure.
very specific.
In my opinion, yes, a lot more specific.
Yeah.
And particularly the thing that it enables is current 3D toolchain integration.
Okay. Great. All right. So what about the Sora?
So I think of this as a category of proxy world models. So you can think of
Yeah.
this as you might sometimes hear LLMs saying, oh, the LLM has a world model inside. And there is some evidence of this in terms of, for example, there's a paper that talks about having, you can see in the internal representation of the model, there's some notion of sort of a grid in a maze, solving a maze-like problem. So these models aren't trained with sort of detailed observation of the world through lots of observations of what the world looks like. So as a result, it's always going to be a proxy or an abstraction of a world model. It doesn't mean they're not useful, but again, it is a quite a different environment or quite a different thing. So I would personally consider generative video as in Sora to be a wholly separate category from world models, and similarly, the sort of LLM usage of the term as well, I would consider that a proxy world model and rather than a world model.
So you alluded to earlier, Jeff, that the training data is all this video online
Mhm,
that obviously people generate tons and tons of video on a daily
mhm,
basis. But what about other data streams? And for example, in the self-driving car world, they have different sensors, right? Like lidar
mhm.
and all of these things. So are those useful inputs too? I mean, I'm not saying that you have access to a lot of that kind of data, but if you did, would that help improve the model?
As a machine learning person, I will never say no to data. As a rule of thumb.
Yeah.
Um,
Or in other words, are there people working on world models in the self-driving car world that have access to both video and lidar and other sensor data?
so I spent the majority of my career developing algorithms in autonomous driving and was lucky enough to be part of building a company called Wave, which is one of the companies that really pioneered the use of world models, period. And in my opinion, have done the most work in specifically using this for autonomous driving. There's a family of models that shared some work publicly called Gaia that effectively do this. So it certainly is useful. 100% it is. If you're trying to build a general purpose world model, which is what we're trying doing at Odyssey, um, adding these extra dependencies on other sensors essentially limits the amount of data you have. So if
I
you're
see.
if you're
I
th
see.
if you're thinking about the sort of the broadest field of data that you could get, LiDAR is probably not the best decision in terms of an input. That said, um, as I said, as a machine learning person, we like data. So thematically, is always interesting and useful. But at the same time, you're multiple orders of magnitude of the scale of observation through cameras.
So in the robotics world, right? So they also have
Mhm.
this kind of data. They're kind of data starved. So
Yes,
as best I
completely.
can tell, they have a bunch of tricks they use. They do virtual training, right? So
Mhm.
some sort of digital twin. They have operators teach the robot, and
Mhm.
then synthetic data.
Yep.
So are these kinds of things uh, interesting to people who are
Very.
building world models?
So robotics as a field, you're completely right to say that it's data starved. One of the things that is unique about autonomous driving as a robotics industry is that it's comparatively easy to scale up data. The reason the reason why is the fact that we have production vehicles and people know how to drive them. So if you want to scale up a large data source, um, don't get me wrong, it's not easy and it's not cheap, but at the same time, it's a relatively tractable route to get a very large source of autonomous driving data. Um, Now, in other forms of robotics, it's quite different. You're dealing with, many different environments. You might be dealing with consumer environments where I suspect your kitchen looks different from my kitchen. And now, if you need to make your robot work well in numerous environments, be it consumer, be it industrial, you do have quite an existential problem of how to deal with this. From my perspective as a roboticist, I think world models are by far the best solution to this, and I think will become think of it as intelligence infrastructure for robotics. So by that, what I mean is using it essentially as a way to bring in all this extra information of observations of how the world evolves, how it works, bringing that to a point where you can take a robot with a relatively small amount of training data for the platform and environment you're using it in, and much more quickly get to a level of performance to getting you to deployability. There is some evidence, really, it's been in the last 3 months, where there's an increasing body of evidence that using world models for this purpose instead of language models, as in VLAs, vision language action models, significantly improves your, let's call it sample efficiency, the volume of data you need with your robot in an environment to get to some level of performance, which frankly is super exciting to me.
So would you classify the kind of foundation model that I guess Chelsea Finn and Sergey Levin in physical
Mhm,
intelligence, they're building a foundation model for robotics, right? So would you
mhm.
consider that a world model?
No, I would consider that a behavior model.
Okay.
So the term in machine learning is often called policy learning. Essentially, you're learning, given some state, what action should I take? and then you're piping that into your robot actuators, and then your robot does a thing, you observe the world, you repeat. So this is the same category of model that, for example, Waves Driver falls into. Very, very useful models, hard to develop. Um, I think world models are an accelerant to it, but again, a different category of model. I would consider them a behavior model rather than a world model.
So, based on what you've said so far, it seems like world models, like you said, are in the GP2 phase. So,
Mhm,
interesting. We're kind of in the experimental phase. You guys have an API, so therefore developers can start playing around with the
mhm.
world models, the current generation through an API, but ultimately not quite useful. Is that a fair assessment?
There are definitely things that you can do with it today. So, for example, we've had external developers come in. We hosted a hackathon at our offices in Silicon Valley, and people built things with it. So, for example, I recall one person built essentially like an interactive weather app, and you could sort of have a sort of a richer, I guess, application experience. I mean, it's a simple application compared
Oh,
to
I
some of
see.
what we've been talking about robotics, but there absolutely are some use cases that are very possible today. Similarly, there's a bunch of things you could think of as building scaffolding to turn this into new versions of computer games. And I'd anchor you in more on if we think about sort of the maybe the birth of computer gaming as an industry. Early games were quite simple, and I think we've often thought, oh, it needs to be 4K pixels and everything. But often it boils down to some quite simple but fun concepts of how a computer can sort of how you can use a computer to provoke emotion and provoke interest and sort of also create interaction between people. And I don't think it's a million miles away from being useful. There are certainly a lot that you can do today, and I would say the pace of development is fast. There's certainly a lot more in the pipe, and I would expect pretty major changes over the coming 12 months.
Yeah, and it seems like the kinds of assets that you generate,
Mhm,
like in that weather simulation, right? So obviously, computationally heavy to
mhm.
do the weather simulation in real time. So maybe that won't scale as a application that you make
Yep.
available to loads and loads of people. But if you use it, for example, to produce content for like a news report, which where
Mhm.
you say, right, so hey, there's a hurricane coming. Here's the weather forecast, and this is what might happen. And
Exactly.
you have actual video. Maybe as a public service announcement, it might be more effective, right? So, but in other words, yes, it was computationally heavy to generate that public service announcement, but you only do it once.
Yeah, exactly. And
Yeah.
I also think it's quite nice having the tailwinds from LLMs. In many respects, that's the industry that's pushed the scale of GPU infrastructure up around the world. It means that there's people solving how to make efficient inference engines, for example. All of these are difficult problems, and at the same time, if we were starting, call it 4 years ago, I think we would probably go through a similar journey as with LLMs. The great thing is all of the work in that industry uh, helps us, and I think the time to go through that same scaling journey and that same maturation will be faster than with LLMs. I think it is there's still some research complexity to come. Don't get me wrong, but it's we're in a more fortunate position, I think, than the LLM folks 4 years ago.
Yeah, but you're kind of you're still in the phase where you have to get the foundation model
Mhm,
uh, work done. And
mhm,
then you have to, after that, follow up with, okay, how do we make if inference efficient at scale, right? So,
mhm,
by the way, so one thing that is interesting to see is on the audio side,
mhm.
audio inference is actually already efficient. You can do it on device,
Yep.
right? So, in terms of text to speech, at least, and even uh, transcription. You can do it on
Mhm.
device, right? So, uh, I don't. I think. Do you think video will ever get to the point? The kinds of things that you want to do will you ever get to be on device?
I think in time, yes. I think there's a continuum, right? So
Yeah.
like I think there'll always be a place for sort of the bleeding edge frontier, right? Everyone wants to use I don't know, Claude 4.6 Opus, for example, and that's probably not going to run on device anytime soon. um, and I think the same will be true for world models, where you have this frontier of large models, which um, realistically need to be served from a data center. But equally, I think there will be a continuum where there are smaller models too. For example, you mentioned audio. Audio as a category is the models tend to be quite a lot smaller than world models or video models or LLMs. Just as the size of model that you need to get to that level of performance, it's a more structured problem. So hence why it's a lot easier to get into deployment. Um, that said, I think all of this really is sort of like an industry chipping away at different parts of the same problem. The fact that the audio folks have worked out how to make it run on device is good for us. It means that device vendors who have gone further into it and are more mature by the time that we need to talk to them. So I think it'll be a portfolio outcome.
So feel free to decline answering this question, but in the
Now I'm
frontier,
concerned.
in the frontier model space, people measure progress to some extent by scale and
Mhm,
scale in data, compute, but also model size, right? So
mhm.
what kind of model sizes are we talking about for the most leading edge world models in your category? So
Um,
if you
as
answer this question, then it will imply the size of your model. So feel free to say no.
no, I mean, I think also if I look at sort of public resources,
Yeah,
anyone who's spending time in the field, uh, there are clear markers of things that are published as well.
yeah.
Um, they're a lot smaller than language models. I think it's partly down to the, I guess, maturity algorithmically. It's just earlier. And we haven't, as a field, we haven't gone through that same R&D journey that LMs have gone through. If you look at models that are in published literature and academia, for example, you'll see small models tend to be single-digit billions. I can point to Cosmos models, for example, tend to fit in that category, up to double-digit billions. But at least to my knowledge, no one has yet published anything or shown anything publicly with three-digit billions, meaning 100 billion plus.
So remind our listeners, what was the size of GPT-2 and where are we on model size today?
I actually don't remember how big GPT-2 was off the top of my head.
GPT-2 was probably single billion, right?
Yeah, I want to say it was about between four, like, yeah, it was single digit billion,
It
I
was,
think.
I mean,
I'm not 100% sure.
it might have been even be in the hundred millions, but it was definitely at most
It was
single
small.
billion, right?
Yeah. So that's quite a good analogy actually then. It's in many respects we've got a lot of room to run. And similarly, I mentioned earlier, we have the unique problem in that we don't have a problem of data production. We have a problem of data selection. And as a result, I think there's a lot of room to run in scaling. That said, I think there's two things you run at in parallel. Scaling gives you progress along some algorithmic trajectory, and you'll, put performance up, but at the same time, it will be governed by how you're building the models today. I think world models have a huge amount of low-hanging fruit in R&D of how you structure the models, how you train them, that mean that it won't just simply be a scaling curve of how quickly we can get up some flops number, but rather it will be how quickly we can ramp the gradient up through algorithmic innovation.
Yeah, one of the challenges right now for even the LLM people is memory, right?
Do you mean GPU
Um,
memory or do you mean
or just they need access to memory because the model sizes are getting
Mhm.
bigger and bigger. So you folks will have that problem too, right?
Yes. So we one of the things that does make this more difficult is that you can think of this sort of encoding information in a series of images into tokens. Token is just a vector of some information. But the information you need to encode a sort of an image is a few thousand tokens, for example, that kind of order of magnitude. So rather than sort of predicting token by token, we're dealing with, predicting a few thousand tokens all at once repetitively. So that means if you're thinking about managing state, I mean, just fairly simple arithmetic tells you that you don't need that many frames before you're hitting the quite long context in terms of managing that. And now, if you want to run that real time, it also adds complications. To us, real time has been something that we consider very, very important. partly because we think the two biggest markets in world models really demand it. Gaming, for example, I mean, imagine having horrendous latency. Similarly, robotics is an industry that deeply cares about this in terms of the runtime performance. And even if they think more broadly, if we think of this as general purpose AI like an LLM, imagine if you went to chat.com and it took you 2.5 minutes to respond to you. It'd be a bit pointless. I don't think we'd nearly see the degree of adoption. So that interactivity and is so tightly coupled with the real-time performance or the ability to serve in an appropriate time frame, which is why we think it's super important.
I mean, isn't it plausible, Jeff, to imagine in the future that a world model is just basically part of a foundation model in the following sense, right? So I go to
Yeah.
Gemini or ChatGPT, they have an interface or an API endpoint, and then it just they kind of understand based on what I'm asking. Oh, let's route this to a world model.
Hmm.
So I won't even know that I'm actually I'm just using Gemini,
Yep.
but Gemini inside Gemini is a world model.
Yes, I mean, to a large degree. In many respects, you can think of this as being sort of the straightest vector towards in machine learning, it's often called multimodal. So
Yeah.
that means like different types of data. So it means vision, it means audio, it
Yeah,
means
they're
text.
already using
Yep.
routers right now, right?
Hmm.
So
Yep, exactly.
you can imagine, oh, Ben uploaded a an image and is requesting something that
Hmm.
is more rightfully served by a world model. So
Hmm.
we'll use a world model, respond to Ben.
Yeah, I absolutely expect that. I think as I said, there's some work to be done to get to that point, but in terms of the direction of travel, I think that's an accurate way of thinking about it. I don't think too many people thought about world models in that framing until quite recently. Um, Often it's sort of been thought about as a singular category, world models for X. Um, but I think if you think about it as a general purpose world model, as we have been doing, I think it leads to at least the outcome that you're describing.
And so, what are some of the kind of key research uh, problems that need to be overcome? I mean,
Uh, there are
again,
definitely some.
going back to
Yeah.
GPT-2 analogy, what did GPT-2 lack that we have now? I guess a lot of things.
A lot of things. And I think the analogy again holds in terms of how you think about world models. This is
Yeah,
early in the journey. This is not GPT 5.2
yeah.
in terms of maturity, and we've got a lot of room to run. So there are a lot of problems that people will talk about in terms of world models of things that we need to understand better. Um, from my perspective, there are two core ones. If I go back to the analogy I used at the beginning, describing this as a model that gives you an intelligent stream of pixels that you can interact with. If you think about it in that way, there's basically two things that come out of it. Number one, you have to be able to do this repetitive, coherent stream of pixels in a way that is plausible. Like maybe it is, temporally incoherent over a long period of time, but certainly in a short period of time, it should, you shouldn't have discontinuities that look weird. So in my opinion, that's one of the foundational pieces of work that just has to be solved. So we've made a huge amount of progress on that. I think there's more work to be done. And that's the foundation on which all of this is built. So the second side of this is interactivity. So now that you've got your intelligence stream of pixels, how do you then start to manipulate it? So at one level, you could think about this as sort of like prompt control, similar to a generative video model. The temporal nature of how these world models are structured means that you have to think about it quite carefully. So that's kind of the two main research problems that I certainly we've thought about and I think are most important. A third problem that you might often read about or hear about in world models is one of long-term memory. My view is that it is important, but it's not the right problem for today. The reason for that is if you're changing sort of the foundational piece of how you're dealing with streaming or prediction of pixels, and by pixels I mean pixels and audio and other forms as well. If that's changing, that's going to affect how your memory is structured. So while I think it is possible, it's great that some folks are doing research in this today, but the reality is I think that becomes a much it's a better problem to solve once those foundations are locked in, and we've still got more work to do on those foundations.
So are the world models, Jeff, in essence, just brute force relearning the laws of physics and nature from video? Well, what if, for example, you can imagine a prompt injection or a poisoning attack where you feed it a bunch of videos that clearly violate the law of physics,
Mhm,
and then producing
mhm,
it starts producing content based on those bad
mhm.
video, right?
Yeah, you're right. So, for example, there are cases where you do want to violate the laws of physics. I mean, I would imagine that most car chases that you might see in a movie typically won't actually have the same like tire coefficients, as in like you skid more than they really should, right?
Yeah,
And that's a deliberate decision by the director for some
yeah,
effect.
yeah.
So, in many respects, this is one of the challenges of building an open-ended world model because I think you the consistent pattern across every category of AI that I've ever seen or worked with has always been that the general approach that is simple and scales with data wins eventually. And it's often harder to structure it that way for the sorts of examples that you describe. But I personally believe that is the right move to make. Now, in that case, you could think of it saying, well, is this a sort of realistic physics or is this film physics, for example? And in film physics, yeah, you do want to skid a car and it might not actually be physically coherent. It looks great, and that's also desirable, right? If you can imagine using that for effect in a ton of different purposes, games, marketing, film, etc. Whereas conversely, if you're then trying to use it as I don't know, simulation of, I don't know, some kind of simulation in engineering, then of course, yeah, if you're violating physics, not very good simulator. So it does depend on use case, and you do have to think about the data domain.
Yeah, LLMs now are we're several years in, so people have learned a bunch of workarounds, right? So there's
Mhm,
retrieval augmented generation.
mhm,
There's a bunch of things that fall under the category of post-training,
mhm,
whatever you consider that to be, fine-tuning, RL,
mhm,
distillation. So, do any of these ideas map over to world models? So, for
mhm,
example, the RAG thing. So, suppose I actually have a repository of video that
mhm.
can be used to enhance the world model. Would there be kind of a RAG kind of thing down the road for world model?
100%. Um, I think it looks different from
Yeah.
how you might think about it in terms of text, but the concept is very similar. So essentially, it's using an external database as some additional
Yeah,
source of memory,
I might
effectively.
be a game studio or a film studio. We have all these
Yep.
assets, right? So,
Yeah, exactly. And you can also think of it as one of the potential solutions for long-term memory, where, if I'm walking through my choose your own adventure game using my world model, and all of a sudden I get back to the start. Maybe I don't want to keep all of that information in context. Rather, it basically gets pushed out of context to a database and then brought back into context in appropriate time. So that philosophical framework, I think, can work in a number of cases. Um, at least to my knowledge, I think I'm not aware of any folks who've tried that yet. But I would bet on that
and
coming in the
what
next year.
about the bucket of post-training? Do any of those
Mhm.
ideas map over?
Strongly. So we think of our training as pre-training, mid-training, post-training. Uh, I don't think the categories are particularly well agreed between companies or potentially even within teams within companies.
Yeah.
Um, we view it as solving sort of different problems that in terms of adding some capability or feature to the model. And the algorithmic training methods differ between each stage. Um, that sort of mental view of how you build a training pipeline carries over quite nicely from LLMs. Similarly, the use of RL to improve the outcomes is also quite nice. To give you a couple of examples, one nice thing is that, again, you can do sort of the RLHF GRPO style reference learning in terms of quality of outcome. The good thing is that you can also make this a verifiable RL process if you use something like a 3D consistent environment where you can sort of provoke the model to do something, and then basically you get a reward based, essentially, you make it computationally verifiable, so you don't have to go out to a human for a response. So a lot of those methods coming from LLMs transfer very nicely to world models as well.
So in the LLM world, right? So it's you've got the proprietary models, and then you
Hmm.
got the open weights models, mainly from
Hmm.
China now. And
Yep.
uh, I don't know exactly the precise metric to use, but let's say the open weights models are 6 months behind, right? So, and it
Hmm.
turns out, according to Anthropic, they're just doing model distillation on Claude anyway.
Yes, I read that in the news. Anthropic does not seem happy,
Yeah, yeah. So, are
understandably.
there open weights world models, and how much behind are they compared to the commercial ones?
I actually think the some of the open weight models are not too far from the commercial ones as well. If I look at sort of the landscape of commercial
And
models,
who's building the open weights models? Also Chinese.
currently mostly Chinese labs. So there's one called Lingbot World that I might be misremembering, but I'm 99% sure they released some model parameters with
And
that.
these are world models in the notion of your definition, right?
They are structurally similar. A lot of the world model developers have looked at capabilities differently. So to give you an example, we've prioritized photorealism as a key non-negotiable requirement. Similarly, we've prioritized real-time performance as a non-negotiable requirement. The final one design choice we made was not being opinionated about an embodiment. Now, if I look at some other world models from other developers, Genie is a good example where they're quite opinionated about the scene and the embodiment, meaning that you're specifying an entity within the scene that you are directly controlling through keyboard presses, for example. Because we view this as an open-ended problem, we haven't prioritized that by design. So even though there are some commercial models, I mentioned, for example, Odyssey and Genie, I wouldn't say there's sort of like a common capability set that is unique across all of them. And the open source models, or open weight models rather, also tend to fit in that category when it's a bit difficult to categorize them. I do think we'll see a bit of a convergence of some of these features in the coming months. And similarly, I do think we'll start to see the emergence of some public benchmarks, which will then further help to sort of align capabilities and allow for this kind of comparison between companies. At the moment, it's honestly difficult to do like for like comparisons. We can compare our models to video models, but frankly, it's not the same thing, and it's not a fair fight.
Yeah,
Um,
there's no LM arena
Not
for
yet.
yeah.
Uh,
Because
I
that relies on some sort of voting
yeah.
style paradigm. What about the metaverse? Is that a
How do
is
you
that
mean?
is that a place where that world models can play a role in terms of generating assets, content?
Yeah, so conceptually, yes. It's a bit different. One of the things that's a little bit different from how current VR headsets, for example, are built is they always run sort of a 3D engine internally. One thing that's different about world models is typically you're getting sort of a 2D stream out. So you're getting a projection. That does mean that there are differences of how they could be used for that purpose. But thematically, I would expect a lot of the metaverse developers to pick this up in the coming months.
By the way, I just realized there's going to be an explosion of video content from those eyeglasses, right? So
Yes.
yeah, because
So we have it even more
Apple
present.
is supposed to be coming out with one.
Oh, I actually didn't know that.
Yeah. Apparently, Tim Cook is wearing it all the time now, but
Nice.
we'll see how it plays out. So, for our listeners, Jeff, in closing, they go to odyssey.ml, they sign
Mhm.
for the API key. So, give us the kind of limitations. So, what's the free tier? What's the paid tier? What's the limitations for the API?
So currently anyone can go on our website. There is actually a sandbox environment. You can just try the model out in terms of directly with a sort of a web interface, not going via the API. If you scroll down to the bottom of the web page, you'll find a button. You can also sign up for an API key directly. All you need is an email. Currently, we're not offering this in
Charging.
terms of pricing tiers.
Yeah.
Essentially, we're offering this to people to experiment, to
Experiment.
explore.
Yeah.
And what we're really looking for is to say, well, what can you do with this? And I think what's very exciting about this category of models is sometimes people think about AI as a productivity enabler in terms of reducing costs. I think that's a bit disappointing if that's the only thing we can do with it. I view this as a more, what can humanity do with this technology that it cannot do today? And really, that is, in my opinion, the most exciting thing as a technologist, and certainly how we've thought about it at Odyssey. So I do firmly believe that world models are a step towards enabling wholly new things that we've thought about some, but I guarantee there are people in the world who have ideas that we haven't discussed on this conversation. And what we're looking to understand is, where does this fit? What are those things that people frankly haven't thought about? In the same way we saw with LLMs, where some use cases are obvious, but some weren't. And that's a very interesting time to be alive and be in the industry.
So for listeners who are interested more in the technical backbone, so
Mhm.
are you using basically the same kind of open source projects that are popular in the LLM space, so the Park Stack, PyTorch, AI
Yep.
model, Ray, Kubernetes. So what are some of the basic components of your infrastructure?
So we train lots of GPUs, primarily NVIDIA GPUs. We use PyTorch primarily. I think particularly for early R&D, it's sort of the dominant framework. The only other framework that I've seen get extensive use is JAX.
JAX, but
Um,
only inside DeepMind.
a little bit outside, but mostly, yes,
And
you're
and
right.
the Chinese have their own
Mhm.
deep learning framework. And then what
Yep.
else?
So that's sort of the training software side of things. In terms of data processing, we run clusters on using tools like Ray or Flight. Think of this as sort of ways to orchestrate what are actually quite computationally intensive data processing and curation workloads. And then we use a bunch of proprietary tooling for managing the data sets that come out and linking them to the experimental process as we go through.
Do the Ray people know about you? I'm an advisor to any scale. They
Oh
should
yeah,
be.
yeah.
They know. Yeah, yeah. Good.
We're in touch with them.
Good, good. Yeah, yeah, yeah. Kubernetes.
Yes, we actually run everything, including training on Kubernetes. I think, at least to my knowledge, I think we might be a little bit of an outlier. I know a lot of some of labs still use Slurm, for example, for the
Oh,
training
yeah,
orchestration.
yeah, yeah.
Uh,
Yeah,
we, or rather, I have a PTSD from Slurm from my PhD,
yeah,
and
yeah, yeah.
I think
That seems like the sign that it's a research kind of project, right? Are you
yeah, we
hiring?
use Kubeflow.
Are you
Uh,
hiring?
we are hiring. We believe in being I think small and very focused teams are some of the most effective ones. So we are hiring, but
R remote or no, on site?
we hire out of two hubs. So our headquarters is in Silicon Valley, and we also have half the team in London as well.
Okay. And with that, thank you, Jeff.
You're welcome. Thank you.